Apart from the structure of NumPy, there are some key properties that are quite essential. Let's learn them one by one. First of all, NumPy requires less memories and facilitate advanced mathematical and other types of operations on large number of data. And typically such operations are very efficient and with less code than is possible using others built-in sequence or built-in functions. And the elements in NumPy arrays are all required to be the same types of the data, unlike the lists or tuples that we have in the Python. And also the number of elements in NumPy arrays, in each of the access are all required to be the same, unlike the Python list or tuples. And also NumPy's arrays have a fixed size at creations. And then if we try to change the size of an NumPy ND array, that will actually create a new array and delete the original NumPy arrays that we have. Apart from the property, there are four types of attributes that we have in NumPy and the array. And first of all, there is the number of arrays of dimensions, that is the n dimensions. And then the other is the tuple of arrays dimensions, that that defines the shapes of the NumPy array. And then the third attribute is the number of elements in the array, that is the size. And then finally, that is the types of the data, that is the data types of an array's elements. So let's see them one by one with the use of some example. First thing first, we import the NumPy as MP, and here we create another 3x3 we create another 3D matrix or 3D array, and we try to use each of the attributes, that is the log n dimensions, log shapes, log size, and also the types. So if I run the cell, you can see that the number of access is 3 of this 3D array, and then the shape is 322, which is just like what we have shown before. We have three 2x2 matrix, so we have a 322 shape. And then the size is actually just the number of elements in the array. That means we can multiply 3 times 2, and then 2 times 2, that is 6 times 2, and then we got 12. So we know that is a 12 elements inside that array. And then the data type, because all of them are integer, and then this means that it's an integer type. Of course, we can also assign these data types to specific types. Say, for example, here we can assign now, say, for example, for these x dot as types, we can assign types as a floating types to another y and the array. So the data types of x is an integer, and then the data types of y is a floating types. So far, we create a way by converting Python sequence. Let's defer to the next videos to understand some other commonly used methods for ND array creations. See you in the next video.